Hello, my name is Jason McKinney. Welcome to our session here today on modernizing to self-managed databases. We have some featured guests here today. Randy Seamans, who is a Principal Solutions Architect.
Hello.
Randy, a Principal Solutions Architect today at AWS. Can you share a little bit about what you do on a daily basis to help AWS customers?
Sure. Principal solution architects here at AWS, particularly in storage, which is what I do and specialize in, by the way. I'm actually a specialist in storage. Assist customers in crafting solutions that are push the boundaries of performance, reliability, serviceability, those sorts of things that people are normally concerned with storage. So if the out-of-the-box implementations don't fit, that's when I usually get engaged.
Thank you. And another featured guest here is Jean Mays. Jean is a senior solutions architect. Jean, can you share and introduce yourself and a little bit about what you do to help Amazon customers every day?
Sure, Jason. Thank you so much for having me. Basically, I'm a senior solutions architect on the Microsoft workloads side. And what I do here, I've been with AWS about 4 years. And I focus on migrating customers to the cloud in whether it's a simple path to EC2 or modernizing to additional database workloads, which I work on primarily. So just kind of help with performance, with optimization, and just a cost-conscious approach to moving to the cloud.
Thank you. Our other featured guest here today is Dennis Mulder, our VP of Customer Success. Dennis, can you share with us in the team here on how you're helping customers every day?
Yeah, sure. So I'm all here to make our customers successful in the cloud, in this case with AWS, using our Volumez technologies at scale. So glad to be here and have this conversation.
So today in our session, we're going to talk about some of the economics around price and performance, as well as data resiliency for modernizing workloads that are moving to cloud and specifically AWS. We're going to lead into a company overview and we're going to lead into a fireside chat.
So thank you, Jason, and thank you for attending this webinar. So who is Volumez? Volumez is the cloud-aware data infrastructure company. We provide innovative cloud storage capabilities, orchestration services, and data management functionality at scale in the cloud. Founded in 2020, headquartered in Tel Aviv, with offices in Santa Clara, California, and New York City metro area. And I'm based in the Netherlands. We have 50+ employees and recently completed our 40 million Series A funding with the investors on the slide. So today, the challenges companies face are diverse and rapidly changing. Right? There's great business opportunity, but with opportunity come challenges. Customers expect more and more from every company, and it's hard for those companies to attract and retain talent. So advanced automation is needed. On the IT challenge side, there's growing cyber attacks, the need for modern applications and modern infrastructure, and various new ways to approach and really leverage the cloud. And then there's societal challenges, economic uncertainty, environmental pressure, the need to adopt data, but also apply ethics. And with the growing space of data and the need to apply AI on it, come a lot of challenges that we believe we can address. So how can we address this with cloud-aware data infrastructure that drives opportunities and greater return on investment? In terms of the business opportunities, we can help provide you with superior customer experiences, increase your team productivity and automation, as well as address improved operational efficiency. In terms of IT opportunities, we can provide enterprise-grade data resilience and protection, higher performance for your applications and infrastructure, and a flexible, scalable multi-cloud environment. We can also offer you societal opportunities in terms of significant cost savings on your cloud bill, greater durability and sustainability, in other words, better green IT capabilities, as well as improved security and compliance. All that underpinned by cloud-aware data infrastructure. So in the recent years, Volumez has been leading in the space of cloud-aware data infrastructure innovation. But you probably wonder, what do you mean with cloud-aware data infrastructure innovation? So in this current era, right, there's increasing amount of data, complexity and cost, and it's rapidly rising. So what we provide with our composable data infrastructure is a revolutionary controllerless storage capability that allows you to compose an infrastructure, just like Kubernetes does this for compute. We do it for compute and storage in conjunction with Kubernetes, if that's what you use, to provide the needs for your application based on a policy engine. So today, a lot of companies use multiple clouds. Volumez is present in the AWS marketplace, as well as supporting other cloud vendors. It is also the default block storage for InterSystems Iris under their cloud services. And we're investing heavily in data management capabilities. For example, we're expanding into Windows by allowing the iSCSI protocol next to NVMe over TCP. And we're adding pooling, tiering to object storage, thin cloning, cross-region replication, and various other enhanced data management services shortly. In the near future, we believe we also need to address the need for AI optimized workloads. And here in particular, we're thinking about increasing GPU utilization, getting closer to the 100% utilization for GPUs. And we do this by significantly decreasing latency and significantly increasing the throughput towards storage. So what are some of the key benefits that Volumez provides using the cloud-aware data infrastructure? We provide guaranteed extreme performance, millions of IOPS, ultra-low latency, and high bandwidth per volume. Think 2 million plus IOPS, 15 gigabytes per second at 0.15 milliseconds latency. In addition, this will offer you significant cost savings, not only in the storage platform, but also in the compute space. By decreasing latency, the wait times for the CPU to get to the data decrease as well, and often this allows you to actually decrease the amount of CPUs inside the workload. In addition, we can help eliminate more expensive license agreements with, for example, SQL Server Enterprise Edition, where thanks to our enterprise-grade data resilience and storage replication, saving on license costs. For example, you could use Standard Edition instead of Enterprise Edition in many of our architectures. We also provide enterprise-grade data resiliency in terms of built-in high availability that is fully policy-driven, disaster recovery and backup through super fast snapshotting technology, as well as super fast restore technology. And we provide intelligent placement on separate failure domains and support availability zones natively. Of course, we never want to lose data, so for that we provide 13 nines of data durability as part of the platform. So now you may wonder, how does this composable data infrastructure work? So on the left side, you see the Volumez portal and the Volumez API in the green cloud that's built on AWS. That provides cloud-native composable data infrastructure or block and file storage. Orchestration is managed by this volume storage control plane, which is running outside of your virtual private cloud, your VPC. So in this VPC, at the bottom, you see 2 zones and 4 NVMe EC2 instances. We typically use the i4i, IS4gen, or the i3en instance types in AWS that have large NVMe drives locally attached to the VMs. Those drives are what we call ephemeral drives. In other words, if the hardware fails or the workload is moved, you lose the data. So we use these high-performance drives to offer you a resilient architecture based on the standard Linux data path to provide you with the high performance. So how do we do that? The first thing we do once those VMs are provisioned is we look at the media profile. We check what is the IOPS latency and bandwidth envelope of the underlying hardware. And we apply intelligent placement in separate failure domains as well as optional in separate zones, so that we allocate the hardware such that we don't hit the same potential issues that can happen in the cloud. Also, thanks to our policy engine and the way we define the performance envelope, we can prevent noisy neighbors. So in the Volumes portal, what you can do is you can define a declarative policy about the needs of the application. So similar to what you do in Kubernetes by saying how much CPU and memory you need, in Volumes you define the performance envelope of the workload. So how does this work? So we have a small connector that is running on top of all the VMs in the infrastructure. And in the Volumes portal, we can then control what the composition is of the data infrastructure. So think of it as this way. This small stack, the connector, will talk to the Volumes portal and API and allows you through infrastructure of code to define your policy. The policy, for example, can say in case of the purple workload that it needs to be distributed across 3 media and across 2 zones. In the blue case, it's spread across 2 zones and 2 media because the resilience need of this application is different. What we then do is we instantiate a native Linux data path. So there's no Volumes controller that sits in between the I/O that the application does and the media. We define a native Linux data path using NVMe over TCP that is providing the ultra low latency. Then, of course, because the drives are ephemeral, we need to provide enterprise-grade data resilience. So again, through the policy, you define what kind of resilience you expect. So think about RAID 1 and RAID 10 type of definitions, as well as super fast snapshotting capabilities for instant restores. We also do cross-zone replication. So now you may wonder what happens if one of those drives fails and the data's gone. What we then do automatically as part of our orchestration engine is we detect that and we will replicate a third copy according to the policy to another drive as indicated by this animation. So with that, let's move on to a demo so that I can demonstrate how the platform works. Thank you. Welcome to this demonstration on how to deploy Volumes on top of EC2. So the first thing you'll have to do is go to signup.volumes.com and register for an account. And there's an approval process in place, so you'll have to wait to get you approved after. Subsequently, what you can do is go to our GitHub page at volumes/volumes, github.com/volumes/volumes, which has our Terraform scripts to deploy the environment. The requirements are Terraform, a shell, for example, the Cloud Shell on AWS account, and Git installed. That's really it. So I already have a Cloud Shell running here. Let me make a directory called AWS demo, cd into that, and clone my Git repository there. Subsequently, I'll go back and go to this Easy Starter folder for Amazon EC2 and VI the Easy Starter file. So this file has the parameters of Terraform to deploy and use each one with Volumes as a prefix for the names of the resources. You can use this to deploy into existing environment and will deploy 2 media nodes of type I4I 2 extra large. Also, we'll deploy an M5N extra large machine as the application node where we'll mount the Volumes into. I'm happy with the defaults and I'll just do Terraform init to initialize Terraform. And when that is done, I'll apply the var file. And then when that is done, it will prompt me for a token. So after you signed up on the Volumez portal, you can log into the Volumez portal, and under developer info, you can find the JW2 access token for the tenant. This enables our Terraform scripts to actually connect the nodes to the Volumez environment. So we'll provide that, and then you will get a summary of Terraform, what it will do. I'll hit yes, and this will deploy the infrastructure into Amazon EC2. And there's not much more to it, really. After this, we'll go to the Volumez portal and configure this environment further. With that, let's speed up, because this will take a while. I'll see you shortly. And we're back. It's now done. The next step we'll have to do is take out the key of the SSH. We have that described here on the page as well. So I can do Terraform output of the SSH key. Let's call that AWS demo.txt. I always find it more easy to actually get the file out instead of all this copy pasting. AWS demo.txt, download. And let me actually jump into this. These are all the files. Open the AWS demo.txt. Keep that handy. And then using puttygen, I'll load the file. AWS demo.txt. And save the private key AWS demo.ppk, so that I can putty into my Bastion host. So let me show you the environment that has just been deployed. I always have to look which one it probably is. MKHZ. These are the instances we asked to deploy, and here's the public DNS name for the Bastion host. So let me put that here. I think I already have the key set to yes. And the connection is good, so let me save that as well. Open it up, and the username is ec2-user. So now, in order to sign into my app node, I'll also need the key. And let me paste that here. chmod 400 AWS demo.key SSH -i demo ec2 user at the app node. And the app node is this one. And the private IP is 209. Yes. So now I'm signed into the application node. Okay, we'll use that later. For now, what I want to do is go back to the Volumez portal and see whether I see the nodes. So indeed, here on top, we see 3 new nodes. The other ones are another environment. So these are exactly the nodes that I see in Amazon. B8, A9, 3D, B8, 3D, and A9. I already forgot them. But let's go back. B8, A9, 3D. Yes. These 3 instances are now registered in Volumez. So Volumez has visibility thanks to the connector. The connector was installed through the Terraform, but you can also install it manually using these instructions here. In the media, I'll also see new free EC2 based drives, assignment free. So these are the drives that are attached to the two extra large, 1.7 gigabyte, 1.7 terabyte drives. Let me hit assign because this takes a while, and then I'll explain what this is doing. So by hitting assign, we will profile the drives. So they're now in assigning mode, and after that will be in assigned mode. So we're profiling the drive. We're really testing what are the capabilities of this drive. So let me show you a previous created environment here. Like here, those nodes are offline, but here you see, let me go on top. Here you'll see the latency envelope of the drives, the free size, the free IOPS, and the free bandwidth. And these machines are used, so the bandwidth is, or the capacity is not high. For the ones that we're currently assigning, we don't see anything yet, but we'll get back to that once it's done. What we now can do is create a policy. So let me show you how to create a new policy. So here's the new policy. I can give it a name, and I first have to define my capacity requirements. In terms of capacity, we have two modes: capacity optimized, performance optimized. It kind of says it. Capacity optimized, we apply erasure coding, compression, dedupe, and things like that to save on capacity. Performance optimized, we don't do that because capacity optimization obviously has CPU overhead. In performance optimized, we don't do any of that. The next setting, I'll do performance optimized. The next setting is how much space do we allocate up front. If I want a terabyte and I put it on 20%, it will allocate 200 gigabyte. Again, this is for pooling purposes, for example, but let's set that to 100. And I have to set my media failures. As you can recall, we have two media instances on two nodes. So my max resilience is basically RAID 1, 2 copies on the same. So I can sustain one media failure, one zone node failure. I cannot sustain zone failures because we didn't deploy in zones. By the way, that is possible, of course, in the Terraform as well. In terms of read and write bandwidth, let me say I need 500 MB per second of write and 1,000 read. I happen to know the capabilities of these drives that we selected. And let's say I need 40,000 write IOPS and about 80,000 read. Or not, let me say 100,000. 100,000. The latency I always leave at 500. You could lower it down, but the capabilities are there. We have this avoid reads across zones. That doesn't apply here in our setting right now. But you can imagine what it does, right? It avoids reading from an application node to a media node that's in a different zone. And we have capabilities to do encryption at rest with keys that are provided by Volumez. If I hit submit, the profile's created, and I now will be able to create a volume. For that, let's first check what I have done, what I have here in my media, because it should be done by now. Let's see the state online. And let's go back here. These are the machines, A9, 3D, now I do recall. And they are assigned, and I should now be able to actually show you the telemetry that we got out of this. So after profiling, which really is a patent-based profile, where we really verify how much can these drives, the physical drives, do. And we found that in terms of read and write latency, we are at 100 to and 25 in write. Right? And actually the second one is probably a bit further away from our environment, so it's a bit higher. It also says we have free IOPS read and write of 130K for each machine and 110K for write, as well as 1200 read, so we should be able to do the 1,000, as well as 1,000 in write. And we always, so we always lower it a little bit in order to make sure that we get the performance. So with this, I should be able to create a volume called AWS Demo, where I assign that new AWS Demo policy, and it's 1.7 terabyte drive. So let's do a terabyte in US East 1A. Now our policy engine will check if you have media in place that can handle this capacity, and it will then take that capacity to create the volume. It doesn't give errors, so it's actually able to provide this. So here's the summary. It provides the input that we provided in the policy on resilience and performance. And here it also shows that it will do rate 1 and that it will use these two media in the 3D and the A9 machines. If I now create the volume will be created and configured for us through the connector, the VLC connector that we have running on the instance types. So now the volume is available, and now I can attach that volume to my instance, my app node instance. So let me pick AWS Demo. Let's take the top snapshot. We also support snapshotting, instance snapshotting, as I've said before. But currently I don't have snapshots, so I'll have to take this. And what it will show here is the B8 instance, which, as you may recall, is our app node here. I can also show the media nodes, so technically I could also attach them to media nodes, but obviously resilience-wise, that's probably not what you want. And I can give it a mount point, so mount/volumes of /FIO. If I go and submit, it will mount that volume into our app node, in which I actually have my session. So I can go to cd/mount/volumes/FIO. ls. There's nothing there, but I have the mount point ready here. And here I did a df. You see the 1000 gigabyte, the roughly terabyte that we have allocated in this space, which will provide the capacity that we have provided earlier. So I switched to full screen mode to show you an FIO test on the environment that we created. For that, I'll go into sudo first because I don't want to mess with the permissions on the mount points, and actually run an FIO. So here's the same directory, right? The mount/volumes/FIO. I'll run lib.io direct1 with an IO depth of 32. This is fairly arbitrary, I must say. 16 jobs because I have a 16 core machine, and 4K random read option on 1 gig files with 100,000 IOPS. Again, fairly arbitrary. I already have the files laid out, so if I hit the test, it will run the job. And here you can see I can reach that 100,000 IOPS that I defined in my policy. I don't even fully exhaust the bandwidth. Again, it are small blocks. It's beyond the scope of this demonstration to show you all of the optimization in FIO. But please feel free to contact me or us to walk through your use case and demonstrate it in the context of your workload and your needs. So let's also see what the Volumes portal will do with this. So we're back here in the Volumes portal. You see some data going here. Actually, these are the 100K IOPS that we have generated in the FIO. But let me show you our monitoring capabilities at a high level. You can go to Monitor, Volume, and I can select the AWS Demo volume. And this shows the details about this environment, right? I have the 1 terabyte, 98% is left. And I see some further details around physical provision capacity. I also see the read bandwidth, the read IOPS. Here we've seen 100K IOPS going through our FIO. We see that it was 4 KB, and we see the latency envelope here as well. Again, there's so much to this. You can optimize this further. Feel free to contact us to show you what we can do. Again, we can hit 2 million IOPS, 15 gigabyte per second at very low latency, but it all depends on the workload, the block size, and the environment. I hope this gave you some insight into an initial setup of getting volumes up and running, and I look forward to the next videos.
Our first question from the fireside chat is that organizations today are continuing to adopt the cloud and are now migrating and modernizing their application and business critical applications like databases. Randy and Gene, what are the different approaches to migrating and modernizing apps in AWS today?
I guess I'll start, Randy. Basically, my focus, as I mentioned earlier, is primarily databases. SQL Server is a huge part of any Microsoft workloads migration. And what we see customers doing is 3 platforms, basically 3 options, which can be rehost, replatform, and refactor. Rehost is basically what you think in terms of a lift and shift. Take your environment that exists in your on-premises data centers and move it as is to the cloud. There's always changes that occur with the cloud, but this could be moved to EC2. This could be moved with a very familiar pattern to what customers are doing in their data centers today. The other is replatform, whether it's going from Windows to Linux or moving to a managed service such as RDS SQL Server or RDS Custom. That's kind of the second approach. Can we take SQL Server, stay on SQL Server, and basically move to a managed service so we remove the differentiated lifting of patching, of managing, of upgrading. And then the final approach is a refactor. Basically, that's moving to Aurora Postgres if you want to stay on RDBMS, or moving to a purpose-built databases. Back in 20 years ago, everything you heard was Oracle and SQL. Everything was running that way. Now, AWS offers more than 15 options for different databases, whether it's data warehouses or RDBMSs such as Aurora, or basically keep our databases like DynamoDB. So that kind of gives you an alternatives for how you basically want to move your workload to AWS from a database standpoint. Ren, do you want to add anything to that?
Yeah, looking at it from my point of view, I'm a storage-centric point of view here. So that means that I'm primarily focused on rehosting or replatforming environments. So typically, the people that I work with and customers I work with here in AWS are doing the rehosting. So they're going to lift and shift a on-premise environment to AWS. And so the closer we can get the environment in AWS to exactly what they have, it minimizes their risk to be able to run in the cloud. So, they may consider replatforming later if possible. So just that first lift and shift is primarily what I deal with here.
Thank you. And Volumes fits in the first 2 use cases around rehosting and replatforming. Dennis, from your lens, what would you want to add to the discussion?
No, yeah, thank you. Absolutely. Fair points made by Gene and Randy. Rehosting and replatforming is where we fit well. So Volumes, as you've seen in their introduction video of the company's Linux, provides a Linux native data path towards storage. And it basically starts where EBS and some other services end, in the sense of if the workload that you're migrating does not fully fit into the cloud platform because of high IOPS needs, for example, that's where Volumes can kick in and leverage the I series in AC2 to still provide the right capability. In terms of our Linux data path, I have some interesting news here. We're looking to expand into iSCSI which would open the door to Windows native workloads. So then you don't have to re-platform to Linux, although that can be attractive from a licensing perspective. But you can run SQL Server, for example, on Windows using iSCSI to mount the volumes in your Windows environment and then go from there to further optimize costs.
There's one other option that customers can consider as well. There's a third-party NVMe over Fabric TCP driver that can be utilized if the customer wants to stick with the NVMe abstraction as well.
Yeah, I'm familiar with that, but I have not tested that yet. But that's certainly on the list to explore.
Yeah, we have several customers using that currently.
So Dennis, what are the storage challenges around migrating and modernizing databases in terms of performance and over provisioning?
So when you look at a database workload, right, it requires some kind of performance envelope. So we would like to look at IOPS, latency, and bandwidth as the key things that you want to provide sort of as requirements. So in the cloud, you have to look into the various storage offerings, right? GPT-2, GP3, IO2, potentially also FSXN in Amazon, and compose your infrastructure that way. So what Volumes provides is a composability layer to compose this based on these three factors, right? IOPS, latency, and bandwidth. And through that, you can typically achieve lower compute needs because the latency is reduced. So the wait times for compute on I/O is lowered. So often you can lower the amount of CPU instances, for example. Lower further the storage infrastructure costs as well by using the iSeries NVMe drives. And through that, we've seen in our benchmarking workloads that could achieve 2 million IOPS, 144 microsecond low latency, as well as 15 gigabytes per second bandwidth usage. And as you've seen in kind of the introduction video, and as you've seen some of it in the demo, we can provide that guaranteed through our policy engine. That is kind of similar to how Kubernetes composes compute. We compose storage. Another number that we've seen on PostgreSQL, we've seen 78,000 transactions per second, as well as on a TPCH subset of TPCH benchmark on SQL Server, we've seen 25 million record inserts per second, even on this infrastructure. So yeah, we can provide solutions to workloads that don't necessarily match out of the box, and you can still move those to the cloud with more predictability and less over provisioning in terms of getting the right IOPS.
Great points, Dennis. Question for Randy. As you hear IOPS, performance, low latency, bandwidth, and transactions per second, are you hearing these from your customers as challenges in moving to the cloud and getting predictability?
Well, I recall that I deal with the solutions that are not met by the out-of-the-box AWS services, that stretch our capabilities. So yes, anything over 1 million IOPS, or ultra low latency or very, very low latency, or gigabytes a second, over 10 gigabytes a second is typically where I get engaged and recommend solutions such as Volumes.
Great.
Thank you.
I'm going to go back to Dennis, and I'm going to ask the question of how does Volumes help control the cloud storage spend if price and cost is such a heavy topic?
Yeah, so It's certainly a heavy topic, right? I think FinOps next to AI are the hot items. I think a lot of customers suffer a bit from a large cloud spend, often because they themselves have given maybe too much autonomy to teams, and teams don't feel the pain of keeping the cost in control, right? They often don't even see the bill. So as I said earlier, what we can help with is optimization of storage resources and increasing performance, but through that also decrease latency and often decrease the amount of cores, CPU cores you need, and or solve some over provisioning needs because of bandwidth needs or because of IOPS needs. Another key factor that I think all our shared customers will love is the elimination of SQL Server and Oracle and Windows licenses by either moving over to Linux, but also moving over from like Enterprise Edition to Standard Edition, or through our replication mechanisms, eliminate things like data guard, so that you can also lower the license cost further. And just to articulate that a little bit better, what we also have, you may have seen it in our introductory video, but reiterating, we have built-in high availability and backup recovery capabilities based on snapshotting, as well as replication across the NVMe drives, also across AZs, so that you can still get the resilience that you need. A frequently asked question, I would say, that people ask us, like, okay, what's your data durability? What if drives fail? And there we've shown that it's very similar to what all the cloud vendors like in S3 and EBS also happens, right? There's multiple copies, so we can reach 13 nines in terms of data durability. So yeah, lowering the cloud bill is certainly a possibility for the right workloads. I've seen 50% plus savings on some workloads. Those are not the tiny ones, by the way, but the larger ones where you can make the biggest impact.
Question for you, Gene. As you are focused on Windows lift and shift or Windows migrations, is the TCO cost conversation coming up as a pattern for a lot of your customers?
Every day, because we're talking about moving to the cloud in terms of management, in terms of we, like I mentioned earlier, the undifferentiated heavy lifting, as we put it. So simplifying and giving you that orchestration layer to manage your services, whether you're going to like RDS SQL Server, whether you're going to Aurora Postgres, those managed services allow for the cloud native options to remove some of the differentiated heavy lifting, but it also gives the customers an insight if they want to rehost, as we talked about with volumes, where they don't have to manage their infrastructure. They don't have to manage sizing. The biggest key that we see is if they move like for like, they're not really saving as much as they would be if they did a performance enhanced or basically a performance assessment for their current workload. And that's where I think volumes could be a really huge help for the customers, understanding where they could remove some of the costs for their SAN architectures, remove some of the the sizes that if they're IOPS bound, as Dennis mentioned earlier, since I'm SQL focused, a lot of my customers run HammerDB, run those transactions to see, can I meet those transactions per minute in the cloud that I can meet on premises? And I think that's what, we could benefit from an alternative like Volumes.
Question back to Dennis. Thanks for sharing that, Gene. We talked about business critical databases, right? And high availability, data resiliency, and data protection for your data estate. Can you speak to how Volumes can address some of these challenges for customers today?
Yeah, sure. I touched on a few already. We provide unlimited instant snapshots and 2-second restores. We can always go back in time, and we store those very efficiently, of course. So Volumes can also easily create multiple synchronous copies of the storage using replication techniques at the storage level, similar to how SANs used to do that on-prem. With the primary database instance, for example, having RAID 1 protection within one availability zone for high availability, and then replication across availability zones for disaster recovery in a typical like active passive setup within the same region. And basically these multiple synchronous copies of the database storage will result in zero data loss and RPO zero, basically. We also have intelligent placement for data availability and resilience. So for example, copies 1 and 2 in AC1 can be placed in separate failure domains within the cloud, so that you know, a top of rack failure or anything else that sometimes happens in the cloud, and then greater data protection across availability zones for larger issues in the network or in hardware or even in the building. Volumes also meets and exceeds data durability. As I said earlier, we can provide up to 13 nines thanks to all of this resilience. On top of that, we also provide various capabilities in the security space, including encryption at rest, and we use open protocols for security for data in transit. And everything is typically deployed in your own VPC, so it's not like we see your data.
Randy, from your perspective, as you hear high availability, data resiliency, and the data protection of your storage needs as a customer, is there anything that you would want to add to what Dennis highlighted as a priority?
Yeah, a little bit. At a recent AWS summit, I delivered a talk on HADR in AWS, a block storage, and I gave a lot of different environments, and some of that included third-party software-defined storage, which is what we classify volumes from AWS's perspective. So a lot of people are looking at doing exactly what we're talking about here. Now, when I started here at AWS, by the way, I have about a 25 or 30 years worth of experience in enterprise storage. When I started here at AWS 4 or 5 years ago, the market really was suspect and did not really believe that you could get highly performant block workloads in the cloud. Well, the tide has turned. You know, the time has changed. Now customers are indeed convinced that perhaps by this method or that method, they can meet their performance requirements, but they now are moving on to the concerns of RAS and cost, you know. So as you know, that's a sliding scale there. The more reliable you get, the more costly. So having a environment that you can configure for various levels of resiliency and replication and redundancy is very desirable to crafting a good optimal solution for a customer here.
Well articulated. I'm going to go to the next question. As we go into customers and you further see these new use cases and modernizing the customer's environments, how is the IT skills gap in IT being addressed from your lens, Dennis?
Yeah, I think, you know, cloud engineers in general are being asked to do more and more with less time. So yeah, tackling all these issues, I think, is where Volumes really shines, right? We took the concepts that the cloud providers really pioneered around infrastructure as code to a new level, where we compose the storage technology as well, that way lowering effort and time and further reducing complexity. That said, I think there's even a further long way to go, for sure. And we will have to, because, yeah, indeed, there's a scarcity of resources and people. But by leveling up, I think we can have more people understand the technologies. On the other hand, I must say, having been in the storage space for quite some time, not as long as Randy, it's you have to make sure that you also understand the under the hood things if you're leveling up in abstractions, right? Because if you do hit an issue, you do need to dig deep. So that's sort of a balance that we need to figure out, I think.
Gene, from
That's
your
kind of
lens, Gene, from your lens inside of AWS, working with solution architects, working with the account teams, working with customers, how is AWS addressing the IT skills gap internally and externally to the customer?
It's a twofold approach, Jason. I mean, first, with the modernization, the managed services, we're trying to remove some of the challenges that a customer would be, required to manage their own environment. What we see also is quite a bit of customers outsourcing and a lot less specialization. With the modernization, with, as I mentioned, with the different levels of databases that are out there, the purpose-built databases, when, I'm kind of like Randy, I've been in the SQL space for about 24 years now, working with SQL servers and SQL 7L. And everything used to be SQL Server. So if you were a DBA, you had a job for life because you were managing the SQL environments and nothing would change. That's no longer the case. With the pricing, especially of, Microsoft licensing and moving, as you mentioned, trying to find ways to alleviate some of the challenges in terms of Enterprise Edition or, HA and disaster recovery configurations. The best thing we can do is to help customers modernize, to help customers look at cloud native solutions. So I think the skills gap between the training that we provide and some of the certifications out there and moving to the managed solutions that will help us, create that orchestration layer like Volumez has, that they don't have to manage everything themselves. Like you don't have to have storage, basically support. You don't have to have database support. You don't have to have Windows support. I think that's how we're addressing it, is modernizing and also the training aspects and certifications and moving to cloud native solutions.
Randy, from a certification perspective for storage, I would imagine that you're seeing, more and more credentials being required, right? As some of these use cases are getting complicated, as they're optimizing in cloud. Do you have a perspective on this?
Yes, I do. So, as recall, I primarily assist in rehosting environments that we're trying to make as similar as to the on-premise environment as possible to get the workloads into AWS and make them as optimized in terms of cost as possible. So that's the little game that we play. And generally speaking, the modernization may be a second wave that a customer may consider once he's come to AWS. So I'm trying to provide essentially a like for like environment. So if the customer has, let's say, 2 data centers 300 miles apart, and inside of the data center he has, purpose-built arrays that have 5, 6, 7, 8 nines of availability, and snapshots, features like that. That's what we're looking to provide the customer so that they can easily migrate to AWS. So now back to the skills gap. So the customer understands the concept of replications and snapshots and RPOs and RTOs. That's the lingo that's been around in this industry for 20 or so odd years, evolved in this industry. So we're going to use the same terminology. We're going to provide the same capabilities to make that gap jump as small as possible. It's like getting on an elevator. If you got a heavy load and you're going to push it on an elevator, you put a little piece of metal across the gap and roll the heavy load in there. And that's what we're doing here. We're providing a seamless migration path to where the customer's existing staff knows how to manage that infrastructure and environment.
How does the AWS partner ecosystem either assist or accelerate migrations and modernization use cases?
That's a good question. Well, we have an all-star lineup of partners, right? So Volumez is one of them. So, we start with the customer's requirements and what it is that they need. And now when you talk about migration, that's a whole nother question itself. And there are migration tools and there are AWS partners, of which we have several that we do. AWS also has a migration tool. that support certain environments. But for the widest support of the most environments, I'm talking about coming from anywhere, going to anywhere, that would be a third-party software-defined storage provider that we could engage at AWS.
Well articulated. The next question goes to Gene. And so Gene is as organizations get started with their database migrations and modernization, and AWS talks to the builders on a daily basis.
Sure.
How is the customer journey being defined, and how do I get started?
Realistically, you would work with the account teams to create, one thing that Randy mentioned, I think he articulated very well. We work backwards from the customers. We determine what the customer needs are and guide them to AWS in the right path, whether it's a rehost, replatform, or refactor. And working with the account teams gives you, the customers the capability of having an insight into Randy, into myself, into some of the other specialist SAs that are out there to provide the architecture, to provide the guidance, to provide the requirements that the customer has when moving to the cloud. I mean, we've mentioned the words lift and shift multiple times here, but realistically, it's a rehost. You're not moving your architecture into the cloud. You're making changes. You're, increasing security. You're making, additional reliability, durability, capabilities of moving to the cloud. So getting in touch with those account teams, they're, basically technical account managers, just helping you understand, the customer understand what the path is to the cloud and how we could provide the right architecture and work backwards from the customer to move into the cloud is the first phase. And I mean, Randy and myself work with quite a few large and small customers. So we're, basically our account teams will pull us in, and as well as other specialist SAs that are out there to help meet your needs.
Thank you. Well, this concludes our fireside chat. I want to close and summarize and specifically thank Randy and Gene and Dennis for your time. I want to make sure that we can help customers that are listening into this, as well as account teams, around the notion of migrating the unmigratable and optimizing your cloud spend. In this session, we talked about TCO and a greater TCO. We talked about surplus third-party pieces of the solution. We also talked about compute, network, and storage resources. We talked about guaranteed performance of IOPS. We talked about low latency and guarantees around that, as well as bandwidth, and transactions per second, which can drive more revenue for your enterprise. We also talked about the unlimited snapshots, restore, replication of your data, high availability, and what that means. And I want to make sure that you walk away with a clear next steps of how you can engage with your account teams and how you can get started in a proof of value or a proof of concept to see some of this complement your existing cloud deployments as you refactor or you replatform your environment, right, for the cloud. And I want to thank you for your time, and we look forward to following up with any questions.